So please post your question in the chat. So we already got the first question from the ESNC. There are two questions for lunar seismology. First one is, can the observed near side seismic activity of the moon be affected by the near side development of sensors? And second one is it feasible to deploy the useful network in the South Pole area? So Kamara-san,
Yes,
please.
thank you very much for the question. So for the first question, yes, it's exactly the bias of Apollo seismic network completely focusing on the near side of the moon. And we think that the lack of seismicity, well, detection of seismicity on the far side is due to this bias of the observation. That is really why we want to have a new station that we can see the first side, also the first side of the moon. And for the second question, yes, I think of course the network on the pole will be useful, but it's not ideal because it will be on the same situation as Apollo era because we have like a focus network which might not cover fully the whole moon to do the observation. So I would say it will be of course be useful, but not ideal. And we are now trying to develop a new method to use this local network to detect more, better, constrain better the global structure, but this is on our way.
Okay. So, second question is for the Yamada-san. So, what are the advantage of having square mirror antennas deployed on the lunar surface versus having a group of free-flying spacecraft?
Yes, thank you very much for the question. That is a very good question. And so there are several trade-off between the lunar surface and also the in orbit. So some advantages on the lunar surface I would mention. The first is depending on the height of the orbit, surrounding satellite may be more affected by the RFI, I mean artificial radio emission from the Earth. And the second point is as I mentioned, we need a fairly long, stable exposure. So it would be better to put the telescope on the lunar surface to have the long period of the observation with under the stable condition. And yes, and finally, if we construct so-called interferometer operations, so a large number of the orbiting satellite interferometer solution may be very needs a very large computer power. So that is why we think having the antennas on the lunar surface have good advantages.
Okay. And there are two additional questions to you, Yamada-san.
Yes.
So first one is for the radio telescope plan, how you plan to deploy over the 10 antennas around the South Pole? Any variation in sensitivity depending on the deploying configuration?
The deploying configuration, yes, there is some constraint, but not very strong. But it is rather more constraint is how to bring such a large number of the antennas to the site to deploy in if we utilize a Rover by the Uncrewed mission. So it depends how far we can go from the base, and also what is the possible mechanism or the mechanism of the loading and the deploying instrument that can be carried by the pressurized rover.
Okay. Second one is from Ryan-san, and what is JAXA front-loading program?
Oh yes. So the Inatomi-san mentioned on the very early part of this session. So the JAXA called the feasibility study of the science of the lunar surface in 2020, back in 2021 or 2. So our team is actually a part of the team selected for that feasibility study. And so this feasibility study program is followed by the front-loading program organized by the JAXA Exploration Center. And Exploration Center, sorry. And so we are in this developing a concept under this program.
All right, so thank you very much for your nice question, and thank you very much for Yamada-san's answers. And any other questions or comments?
You have plenty of time for questions and comments, so invite people to offer them. And if you were present yesterday, please feel free to ask questions. If we can answer them, we will.
Okay, next, new questions has come. So question to Morita-san, change 6 has already returned sample from SPA. Is it necessary to return sample from SPA again?
Yeah, good question. Thank you very much for questions. Yeah, as you know, the sample collected by JAXA was taken from the Mare regions within the Apollo Basin, and within that sample, a few particles dated to 4.2 billion years was identified. And this age has been interpreted by the formation age of the South Pole Etoken Basin. However, the origin of that particles remains unknown, and therefore it is unclear what specific event the estimated age corresponds to. So to reliably determine the age of the SPA basin, it is essential to first identify where the SPA impact melt seat has been preserved as a geological unit, and then to conduct a sample return directly from that unit originated from the impact melt seat. Yeah, in my opinion.
Good. And the next question is for Nagaoka-san. What size core sample are you envisioning to the correct with the coring drill?
Thank you for the questions. We need the sample size, weight. Weight is required as over 100 gram because it requires several kind of the analysis. So we plan to the coring system, and we plan to the coring system size is more than the 2 cm diameters, and the length is over the 10 cm diameters. I hope this size. Thank you.
Okay. And the next question is, what precautions are being taken to protect the ultimate pressure rover from the real dangers of the lunar dust?
I would invite our speakers if they can maybe speak to the instruments that they've thought about and dust
Sure.
impacts on the instruments.
If I may, so in terms of seismic observation, I think the biggest risk of the dust is more the dust covering the solar panel, which will decrease the efficiency of the power generation. For this, we're not significantly concerned about it, being that we are pretty low in the we're not with so large size, and at this moment we are not taking this so much into account, unfortunately. I don't know if this answers your question.
Thank you.
Okay. And next one is from Namik-san, and the question to NASA and JAXA. Some instruments are not safe for the astronauts. Is the rocket merely to the shutdown during the manned phase, or are there safety regulation for the instrument on the rover even during the unmanned phase? Good question, big question. So
Okay, I wonder if this is addressed to the speakers, but if I were to
please.
answer, yes, because one of the key question we had is that we have to ask look, if it's a manned mission, we have to ask the astronauts to deploy our seismometer. And for this, we had to go through some safety issues. For example, the mass of the seismometer, or we had some a limitation of how far the astronaut can reach, or how he can lean down to put something on the ground. So I think this will significantly change if we assume like a robotic arm on the pressurized rover that will be deploying the seismometer on the ground. But again, this has other constraints, like a mass that the arm can pick up, or how far it can reach. So I would say we have already made some study on the trade-off, what will be the constraint for manned and unmanned mission in terms of seismometer deployment. I hope this answers the question.
Go ahead,
Right.
Nagaka-san.
Can I reply to for Namiki-san's comment? Okay. So our plan, or just ideas, our plan to analyze on-site for the sample selections is performed during the unmanned observation period for the pressurized rover. So when the astronauts in pressurized rovers are during the unmanned period missions, the astronauts is performed the attach the meant of the instrument, the changes the other instruments. So to just idea. So so we our plan to the sample selection is during performed during the unmanned period. Yes, thank you.